All right, page 69 in your books. We're going to finish up this discussion about margin of error. And then you guys will have the remainder of class time to review for your test on Friday. You can work on your study guide. And then tomorrow and Thursday, I'll take questions from the study guide or any questions from any of the homeworks that you guys want to know how to do. I'll work those out, and then you'll have your test on Friday. All right? Okay. So again, this is on page 69 in your books. This right here is technically for part C, but there wasn't a whole lot of room on part C, and so if you drew this down underneath part D, totally fine. And we had just started talking about this at the end of class on Friday. Oops.
Hello. The pencil told me to correct me fast enough to
Yes.
I'll be back. I'm just trying to get my glasses.
Got it. Absolutely. Give me just a moment. I'll get that written for you. So if you guys look at question D, which I realize we drew in there, that's okay. There's still plenty of room to look at the question there. Remember, we did yellow Skittles instead of blue M&Ms. So looking at this, what kind of trends do you notice? Is it very, very spread out? Is it all clustered together near a certain value? Is there anything that surprises you when we see this? It's kind of spread out, right? Does anybody remember the company that makes Skittles has said what percentage of each package is yellow? Does anybody remember what that was? 20%. Skittles says 20% of each package is yellow. This is part D. Part C was the dot plot, but again, they didn't give us a lot of room for that. So now we're talking about question that's in part D, but our picture is also there. Good questions. Looking at the results of our class, you guys each had a random sample, right? I took my little Dixie cup, I had a big bag, and I reached in and just got a random sample for each person in here. Why didn't all of these come out to be exactly 0.2? Somebody got a 0.08. Somebody else got a 0.30. So we have 8% from one person, 29 and 30% over here. Why weren't they all exactly 20%? Because they were random. There's going to be some natural variation when you do random sampling. I believe that is question E. Yes. There's going to be natural variation due to the random sampling. So for part D, we noticed our results are kind of spread out. For part E, not everyone got exactly 0.2 because of the random selection. So if the true population proportion really is 20% yellow, I would expect when I do a random sample that some would be more, some would be less, some are going to be right on. Did we have anybody that got exactly 0.2? We had one person right there. Yes, ma'am. Oh, yes, you had exactly 0.2, which I thought was awesome. Were there people that were close to 20%? Looking at all of this, if instead of giving each person a little random sample, if we had been crazy enough to do the whole bag as just one big sample, do you think that this person over here that had 30% yellow and this person over here that had 10% yellow, or sorry, 8% yellow, that would have kind of evened out? This person didn't have very many yellows. That person had a lot. If we put their samples together, it would have been much closer to 20%, right? All right. For our margin of error, we're going to go to the next page for this. So you're going to be on page 70 now. We estimated the mean here. That's part A of question 2. We estimated our mean to be about 0.21 for the whole class. So we said about 21%. Question 2, part A is this right here. And then we wanted to capture 95%. So almost every bit of data, but not the very top and not the very bottom. We're going to capture almost all of it. We said we wanted 14.25 dots. I think we ended up grabbing 13 dots. You're always going to leave out like the very top and very bottom, but you're pretty much going to grab everything else. How far apart are these two on the number line? How would I figure that out? The top value that I'm including, the bottom value that I'm including. Let's see. If this one is 0.3, what was that one? 0.29. This down here, here's 0.1, here's 0.12, so this bottom value is where? 0.11. So I'm going to subtract those because I want to know how far apart they are from each other. So I would get what, 0.18? And then I'm going to split that distance in half so that I can look at that far on either side. So I'm going to take 0.18 and I'm going to divide it by 2. What would that give me?
9.
Yes, 0.09. This is our margin of error. Margin of error. That goes with part B on number 2. We have our high value and our low value. Our high value was 0.29 and our low value was the 0.11. Our justification for going that far out is that we have captured approximately 95% of our data. I'm going to switch to the page that looks like yours because I feel like I've got a lot going on up here. Let me get this up. All right. So we estimated our mean. That was 0.21. Capture an interval, a low and a high value. So we went from 0.11 to 0.29. This captures about 95% of all of our data. That's our justification for it. And it says right here, you will want to leave out the extreme cases. So we left out the biggest and the smallest. We captured everything else. So we found our margin of error by subtracting those and dividing it in half. So we would say that the mean proportion of yellow Skittles is 21% plus or minus 9%. Let me pop that up just a little bit higher on my screen. There we go. The mean proportion of yellow Skittles is 21% plus or minus 9%. That's the 0.21 plus or minus 0.09. So a class at W. Wonka High School, which is in Hershey, Pennsylvania. Have you guys ever been to Hershey, Pennsylvania? Ever heard of it? The streetlights are shaped like Hershey's Kisses. And they have like one of those boat rides, like you get in a little boat and it goes around a thing, like an amusement park thing. And they show you how the chocolate is made and they take you through different parts of the factory. It's pretty cool. They collected data on the proportion of red M&Ms. They did something similar to what we did, only they used red M&Ms. They found that the true proportion of red M&Ms is 15% plus or minus 13%. So this was their margin of error. Cody, who was a student in the class, claims that the majority of times that samples of red M&Ms are collected, so you buy a package of M&Ms, you dump them out, you count all the red ones, and then you count all the M&Ms total, and you divide it, that the majority of times that you do that, you're going to get a proportion somewhere between 2 and 28%, but not all the time. Why not all the time? Anybody know? How much of the data did we say we were capturing when we did our margin of error? 95%. So there's always going to be like these weird situations where you're going to get something that's like, man, half the package is red. That's not a common occurrence. It's a very, very rare occurrence. But 95% of the time, you're going to get somewhere between 2 and 28%, looking at what their margin of error was. I want to use similar reasoning to what we did with the yellow Skittles. So we have a proportion of 21% plus or minus 9%. So I'm going to say if we repeated taking samples of Skittles the proportion that would be yellow would be between what and what? How did they come up with the 2 and the 28? Yes, they took 15 minus 13. That's how they got the 2%. They did 15 plus 13. That's how they got the 28%. So for ours, what would we need to do? Yep, 21% minus 9%. What would that give us? 12%. So it's going to be between 12% and what? 30%. Most of the time, but not always. So when we say most of the time, we mean 95% of the time. Does that seem reasonable with what we saw? Were most of our values in between 12% and 30%? Do you want me to pop our graph back up there? There we go. Were most of our values in between 12% and 30%? Yeah. In fact, if I include everything between 12 and 30%, I'm only leaving out how many points? Just 2 of them. So that is very, very close to what we saw. We've got one last question to answer here. If we increased our sample size, do you think that would change the estimate for the population proportion or the margin of error? If instead of giving you one little Dixie cup full of Skittles, if I'd gotten like a regular sized cup and I'd filled that up with Skittles for everybody, how do you think that would have changed what we saw? Do you think that our graph would have been even more spread out? Do you think we would have seen things much closer to 20%? Do you think they would have been bigger or smaller?
I think they would be closer to 20%.
Probably closer to 20%. So we think larger sample sizes would move the estimate of the population proportion closer to 20%. what do you think it would do to the margin of error? Do you think our margin of error would need to be bigger? Would it be smaller, or would it be about the same? Remember, we find the margin of error by first taking all these random samples and plotting them. And then we want to capture 95% of that data. So we would leave out the biggest and the smallest, and we'd take pretty much everything else. Do you think that that would be more spread out than our old graph, or less spread out? What do you think? More spread out? Let me pull up our graph again. I want to look at it. Do you think you would have had people up here? It's probably possible. Do you think we could have had people down here? Usually what we see happen with our sample sizes, and again, this is usually, this isn't always, this is why things need to be repeated, because you need to see what happens over and over and over. Because 0.8 is not the true population proportion, but somebody really had that observed value. It can happen, it's just not common. Most of the time, as our sample size gets bigger, our data becomes more clustered around the true population proportion, and usually the margin of error will shrink down, because you usually don't have to grab as far out to get 95% of your data. Is that true 100% of the time? No. But most of the time, as your sample sizes increase, your margin of error will decrease. Most of the time, as the sample size increases, the margin of error decreases. Do you guys remember the 2016 election? Anybody remember who was elected in 2016? How many people were surprised by that result? That's not at all what had been predicted, was it? When these big organizations that do polling were trying to figure out who's most likely to win and who's most likely to win in these different states, is it going to go red, is it going to go blue? They calculate a margin of error. They knew that they might be off from the true vote. Their margin of error was not large enough. The reason that they ended up being wrong in their predictions, they've discovered since then that their sampling needed a lot of work. They were using methods that were statistically sound, but when it actually came to collecting that information, they didn't do a good job of getting a true random sample that represented the population. And while they talked to a lot of people, they did not accurately account for the size of the margin of error there. We saw the same thing happen in 2020 with that election. They still were trying to predict, are these states going to go blue? Are these states going to go red? Most of the predictions that I saw leading up to the election, they were trying to be much more conservative because they'd messed up so badly in 2016.
I'm not right. Wasn't like this election that we recently had, wasn't like a lot of states turned?
Yeah, there were a lot of states that flipped from what their predicted outcome was going to be. There were a lot of places where there were upsets in the results. And there's all kinds of research being done and articles being written to try to figure out, why were we so far off? One of the theories that's been put forth, and this is something to definitely keep in mind if you ever get into or read anything about public opinion polls, if you want those results to be accurate, people need to feel comfortable telling the truth. If they don't feel comfortable telling the truth, then the information that you get from them is no good. and you can't use it to make predictions. That's one of the things that they discovered. They said, we're not really sure that some people that intend to vote this way or that way are comfortable telling someone else. And then they look at a lot of other things that could be influencing. One of the things that they discovered after the 2016 election, they were doing too much of their polling in urban areas and not enough in rural areas. And so that's one of the things that skewed their results. Pay attention the next time you see results of a poll, they'll tell you what the margin of error is. And sometimes that margin of error is big enough that you're like, okay, you said this, you could really be wrong. Like really, really profoundly wrong. So just kind of keep that tucked away in your mind. You guys have the rest of the class period to work on your review. So the last 20 minutes of class. I'll be moving around in case you guys have any questions about that. You're welcome to work together. You're welcome to use your notes, anything on Canvas. Tomorrow, I want to open it up and take questions. If you guys don't have any specific questions when we come in tomorrow, then I'll start hitting the ones that I know historically students have struggled with the most when it comes to the test. All right?